Now, why do we add plus c to indefinite integrals? So when you're given x to the power n, integral of x to the power n dx, the answer will be x to the power n plus 1 over n plus 1 plus c. So the question is, where from this c? Why plus c? Okay. Now, let's first of all understand that integration, okay, integration. So it's a reverse of differentiation. Okay. All right. So let's start with the family of curves. Now we are saying that integration is a reverse of differentiation. Now let's confirm that. Now when we're given y equals to x cubed, okay. Now when we find dy dx, or when we differentiate this one with respect to x, it will be dy dx equals to 3x squared. Okay, that's the derivative of this. Now it means when we integrate this, we should get this. That is the idea. Okay, now let's start by integrating this one. Okay, so let's write it well. Dy dx equals to 3x squared. So let's multiply this side by the x, okay. So this side will cancel. I believe it. Dy equals to 3x squared dx. So dy 3x squared dx. All right, so let's take integral on both sides. So have this, and anytime the integral sign and d meet, they cancel out. So we have y here. Now with the rule for the integration, so we have to add 1 to the power and divide by the total. So that would be 3x cubed over 3. So this one will cancel. So that will be x cubed plus c. So this plus c could be 0. So this side can be x cubed plus 0. Remember, the original function is x cubed. Okay, x cubed. So we have x cubed here. All right, now let's use the idea of family of curves. Now a function of y equals to x squared plus 2, y equals to x squared minus 2, y equals to x squared plus 4, y equals to x squared minus 4. All right, now if you are to sketch, okay, the first one, so this one will behave like this. So we have y equals to x squared plus 2. So so 1 2 like 1 like 2. So x squared plus 2 will pass through this, name like this. Okay, because y equals to x squared, we assume that is plus 0. That will pass through the origin here. Okay, so minus 3 minus 4 and what have you. So x squared minus 4 will pass through this. Okay, then minus 2 will head this way. All right, so we have y equals to x squared minus 4, y equals to x squared minus 2, and this side is y equals to x squared plus 2. So we have the positive part. Okay, so this is the origin. So up here is the positive part and the down here is the negative part. So this plus 2 minus 2 plus 4 minus 4, they are all constant. Okay, now since integration is the reverse of differentiation, okay, now let's take the derivative of the first one and see. So dy dx will be 2x. Okay, so this side 2x, this side 2x, this side 2x, because the constant here will give us 0. Okay, so 2x, we have 2x, 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 2x. Okay, now if you are to integrate any of them, say the first one, so dy dx equals to 2x, so times dx times dx, so this side will go, dy will be 2x x. So let's take integral on both sides. So the d will cancel, the integral on y will be, so we have 2x squared on 2 plus c, so this one will cancel. So we have x squared plus c. The c stands for the constant, either plus or minus. That is a constant. So that is why we always add c to show that it's a reverse of differentiation. Okay, that is the rationale behind that. All right, so that's the idea. Okay, now we can also talk about so many examples. Okay, you can use so many examples to show the reason why we add plus c. Okay, we add plus c to our integration. All right, so that's that. Thanks for watching, and don't forget to subscribe for more exciting videos. All right.